So our first speaker today is going to be Bahareh Jozranjbar, who's a doctoral student in psychology at the University of Iceland in the laboratory of Dr. Heide Maria Sigurdardóttir. Icelandic names, thanks. So without further ado, Bahareh, please take it away.
Thank you. Hi, everybody. My name is Bahareh, and I'm going to talk about the inseparability of featural and configural visual processing in dyslexia. Dyslexia is a problem in reading that occurs despite normal intellectual capacity, intact sensory abilities, and adequate educational opportunities. Dyslexia is often described as a phonological deficit, which means difficulty in manipulating and distinguishing phonemes that are the smallest units of speech sound. High-level ventral esteem regions in or close to the left fusiform gyrus that are important for recognizing objects tend to be underactive in dyslexic readers. This is consistent with some studies showing that dyslexic readers might have problem in object and face recognition. This is debated and not all the studies found that. In this study, we investigated whether dyslexic readers have problem with specific stimulus categories. If dyslexic readers' problem are visual, they could be restricted to visual word processing, or they might generalize to other visual categories, all or only some. As face recognition is assumed to require domain-specific mechanism, so faces might be distinct from other visual categories. We were also interested to see whether dyslexic readers have problem with featural or configural processing that are two different approaches to visual recognition. Featural processing is generally assumed to be important for word recognition, while configural processing is often considered the hallmark of face processing. Visual features of word is something like letters in the word. Just by changing one feature, we can change the identity of word. For example, here, by changing one feature, which is C, we change the identity of word, and now it's bat. For changing the configural processing, we change the distance between the features of object. But this does not necessarily change the identity of word, as you can see in the cat word. It seems that configural information is less likely to influence reading ability, but there is evidence showing that experts use greater holistic or configural processing to read. In our task, we manipulated featural and configural information of faces and houses to answer our questions. For example, here we changed the featural information of faces. You can see that eyes, nose, and lips are different between these two faces. Here we did the same for houses. Windows and doors are different between these two houses. Here we change the configural information of faces. As you can see, features are the same, but the distance between them are different. For example, we change the distance between the eyes, nose, and lips between these two images. And we did the same for houses and changed the distance between windows and doors, while features were the same. In our task, we first showed them a fixation cross for 500 milliseconds, which was followed by a sample that could be a face or house for 300 milliseconds. Then there was a visual mask for 200 milliseconds, and then we showed them two images, where one of them was identical with the sample, and another one was different, featurally or configurally. The images remained on screen until the participant indicated which one was identical with the sample. Comparing the overall accuracy of both groups revealed that there was a lot of variability, but on average, dyslexic readers were worse at recognizing houses, but probably they had no problem with faces. However, it seems that it doesn't matter whether it was featural or configural processing. We did not expect this result. What overall accuracy misses is that by relying solely on overall accuracy, the relation between different conditions will be overlooked. Here, for example, we have two conditions, A and B. The darker color means that they are more correlated. If we only compare the overall accuracy of A between two groups, we will miss the relations between A and B. Two groups might be equally good at condition A, but use different strategies for doing that. If A and B tap into different skills or require different strategies, accuracy of a trial of task A should be more correlated with the accuracy of another trial of task A. than a trial of task B. Then the left pattern will be our conceptual model that assumes A and B are independent skills or conditions. If A and B are not independent, but instead tap into the same skills, then a trial from A should be no more correlated with another trial of A than it is with a trial of B. And we would see the right pattern. How will this pattern correspond to the real data is what we are looking at in the representational similarity analysis, where we compare the conceptual models to reference models. Reference models are the correlation between feature and configural processing of faces and houses for dyslexic readers and typical readers. Darker color means that they are more positively correlated. Here, for example, there is a low correlation between configural face and configural house. And here, there is a high correlation between the featural face and configural face. These are the conceptual models for stimuli, process, and difficulty level. If these patterns correspond to reference models, that means that they are independent skills. Here, for example, is the conceptual model for a stimulus. These two are both faces, so they are highly correlated. And here, one of them is face and another one is a house, and they are not correlated. It is the same for the conceptual model of the process. These are both features, so they are correlated. And here, one of them is featural and another one is configural, so they are not correlated. And it is the same for difficulty level. What we found was that for typical readers, the stimulus conceptual models corresponds to the real data. Some typical readers seem to be good at face recognition and some at house recognition, but they are not necessarily the same people. This shows that face and house recognition are two separate skills for typical readers. We found that pattern of the conceptual model of process in the real data of typical readers, which means that they act differently based on different processes. We did not find the pattern of conceptual model of difficulty level in the real data of typical readers, and we did not expect to find this pattern because if a participant performed well on easy trials, then he or she might also perform comparatively well on more difficult trials. We also found a stimulus pattern for dyslexic readers. However, we did not find any indication that dyslexic readers act differently based on different processes. We also did not find the difficulty level pattern in dyslexic reader data as we expected. The representational similarity analysis showed that typical readers acted differently both depending on whether the stimuli were faces or houses and whether feature or configural processing was task relevant. Dyslexic readers performed differently based on a stimulus category, but not process. It seems that dyslexic readers solely relied on one process when analyzing the stimuli. It is possible that if dyslexic reader cannot flexibly change the way that they process a stimuli depending on what is relevant, it affects their reading. As to read efficiently, both feature and configural processing are required. I would like to thank my supervisor, Heida Maria Sigurdardotter, and Arne Christiansson, and my collaborator, and thanks you for listening. Thank you.
Thank you. I think we will have to stick with sort of virtual applauses at the end of these presentations. So we have a question for you in the Q&A. Have you considered doing a similar featural versus configural contrast in a word recognition task? What would you predict there in accuracy and RSA?
We did not do that. We didn't do that, but we are going to do it. It's an interesting possibility, and I think that it should be the same, and they shouldn't be able to discriminate between feature and configural processing, as they weren't unable to do that for both faces and houses, and it shouldn't be that different for word recognition, I assume.
Thank you. So I had a question that may sound a little bit silly, but so a basic concept in architecture is that they sort of design houses to be a little bit face-like. You know, they have two windows and a door in the middle that kind of symbolizes a like a nose, and sort of the whole shape, you know, in a very abstract way kind of resembles a face. And I'm kind of wondering whether this could potentially confound your research a little bit, that you know, at some very abstract level, faces and houses are quite similar, or is this similarity actually intended in your task?
We actually did that for, we had the house recognition for control, and we chose that because it was some sort of like the face, and we could change the feature and configural information of houses, just like we did for the faces, but it wasn't easy for other stimuli. But in our future study, we are going to do the same analysis on different type of the objects to see what will happen.
All right, great. Thank you very much. So if there aren't any more questions.